Hi everyone, it's me again. In this occasion, we are gonna uh, fix or solve some problem of mathematician things. I mean, from math. I am going to show you the determinants. Determinants is a topic that is kind of complicated, but being honest, is one of the most interesting the most interesting topics of math. I am going to show you an exercise here. Let me show it to you fast. This one here, I did it on my notebook. Okay, so a school book. Let's call it like that. A school book. I'm going to look for the whiteboard here, and I'm going to write down here in this right whiteboard, which is free. I'm going to write down um the same matrix that is here. Okay, this is called matrix, but at the end, this is not like super complicated. Okay, we're gonna go here, then we're gonna go here like this. Okay, let's put this here. And let's go now, for example, to the A. Let's put it bigger, and now let's copy and paste, and we're gonna make like three columns. Okay. Number four, number one, and number one. And put it, let's put that kind of figure and in the center. And let's copy it. Sorry, let's copy it and paste. Copy and paste. Okay, now let me put this. Okay, like this. And in here, let's put, for example, four, three, and two. Then we're gonna go two, three, and one. Let's um let's put it kind of smaller because I don't like how it looks. I am very aesthetic sometimes. So let's go here. Okay, we're gonna put that like this. It doesn't matter much like the font size at this moment. Okay, so and how we call this? This is a three, 3 by 3 matrix. Okay, 3 by 3 matrix. Oh, sorry. Let's let's use this one. Oh, we got another color. Um, let's put it. Thing is that I don't have a tablet here. Okay, even though I am using the mouse of my computer, which is very difficult to write a line with that. But it's possible. I mean, I can even use these type of lines, but I don't like. I mean, that would be like no, not necessarily what I need. Okay. As I said, this is a 3 by 3 matrix. Okay. But the most important part here is that this matrix is like such. For example, let me try to make an arrow here with this. I don't know if it is with this. No. I want to make an arrow down. Yes. With now I can do it. and an arrow to the left. Let's move this here and let's go here to put it like this. Okay, usually the arrows point down and right to the right. Why down and to the right? Because we we were created by a God that is up, right? And if for example some things happen, something bad happens, usually we are commonly feeling comfortable below instead of up because we don't know what is uh, on the universe. Even though it's kind of curious and interesting. It's like the roof of a house. You get to the roof of the house, and I mean, in there you can't sleep. I mean, you could do it, but it's not the same. You will feel cold and many things. But inside of the house, you will feel hot and you will feel better. You will not get sick and all those things. But also, there is a limit here. I mean, it's not for you to be on the 0%. Life is like that. So it is just an illustration. So why is important to write down this? Because here this has a this has like a value that we have to remind always. This is, for example, minor. Sorry, and here we put a plus. This is a law. Why it is a law? Because if you watch a clock, for example, let's look for a clock here. Clock from all times. Illustration. For example, as you can see, the clock moves to the right. I mean, 12, 1, 2, 3, 4, 5, 6, 7, and then it starts again in 12. Here happens the same thing in the determinants. Sorry, we do the same. So let's go and put this even more clear. We're gonna put here minus again, and let's put the plus. As you can see, even this application automatically was trying to put the signs in the right place. So what we can do with this? Look, it is super simple. We're gonna make the operations like such. We're gonna start by the 1 here, then we're gonna go for 2, and so on. How? Look, we're gonna go 1, for example, it says as 1, okay? Then 4 plus 1 is 5, minor 2 is 3, and 1 by 3 by 1 is 3. So these sides here indicate that the first number that we got is 3 because we started from here. Now we're gonna do it from the upper side, from this side. I mean, let me use the arrow. We're gonna use this, okay, like this. We're gonna go from here. Oh, sorry, from here to there, to there. Okay, from here to there. We first start is in the opposite direction. This is the second arrow. I am going to put it in yellow, for example. And let me see if I can put it like a border. I don't know. Well, I can by the moment. So let's put a yellow that is in there, even though you don't see it very clear. Uh, we can copy, for example, this, and now let's put this here. And instead of yellow, it will have, for example, um, let's say green. I don't know if you get it. Why green? Because green means like green is first than yellow. It's like in the like in the transits. You know, I'm not gonna talk much about it, but it's true. You first see the sign in green, and then it appears yellow, and then it goes to red. I mean, it has its order, and it follows its order. After it goes to red, then it goes again to even I can simulate that. Look, I can even put here this like that. So it goes yellow, then then sorry, um it goes um green, then yellow, and then red, and then vice versa. How can we see the vice versa? The same thing here, but we're gonna do it vice versa. We're gonna put that this. Remember that everything has its context. I am talking about the determinants. I am not talking about the transit. I mean, I have set that, but it is not going to alter it. There are people that maybe are gonna think that, but I know that it will not. Okay, so as I said, the yellow side is kind of like the interception here, but it starts from the green side and then goes to the red, and then from the red it goes to the green, and so on. The yellow side has like a two pivots because even though we don't see it, kind of, it is kind of like the signs. I don't know if you get it. We see, for example, minor here, plus here, right? And minor here, and minor here. What happens sometimes in the signs are not shown. That's why I don't have to put this yellow side to this side mandatory. So if we continue with the formula here, we just have to make like, for example, two minor. Sorry, it is actually it is by 2 by 3 by 1 is equal to 6. And then we say 3 by 4 is equal to 12. And that is equal to, if we summarize, 6 by 12, 6 plus 12, it is equal to 18. Okay? So now we're gonna go here. 2 by 4 is equal to 8. And if we summarize 8 plus 16, it gives us 24. Now, sorry, I have to put here the multiplication sign. Now let's go to the other number that is here. We have two determinants. Determinant of A, but that determinant of A from one side and the determinant of A from the other side. I mean, you have to put it like if you are determining from the green side and from the red side, for example. So now the last one here is equal to 3. Why is equal to 3? Well, because we're gonna make um we're going to apply the law, the sign of the signs here, and the same thing that we saw here. So we're gonna say 2 minor 3. Why minor? Because here you can see it's minor. Okay, 2 minor 3 is equal to 1, and 1 minus 4 is equal to 3. And this multiplication 1 by 3 by 1 is equal to 3. So at the end we got 3. So this is the determinant H, determinant A. Okay? So let's make the vice versa, the same operation, but to the other side. I mean, but the opposite side. For us to do so, we just need to um, start in the opposite direction. Here we want to make, instead of starting with a minor operation, we're going to start with with a subtraction. We're going to start with multiplication. 2 by 3 is equal to 6. You got it? And then we're going to say 6 by 4 is equal 24. But we got no, it's equal to 18. Sorry. So we have here, sorry, we have here 6, and then we place 24. Instead of 24 is 18. Sorry. I am not a super good in mathematician, but I know that what I'm doing is all right, because when I did it with the same explanation that I'm trying to explain to you. Even though sometimes the explanation is not totally clear, it is because I do many other things. I mean, I can be a perfect man. Jesus himself said, "There is no one perfect, but only God, Father." But let's try. Let's try to do it and to explain it to you, because it has its meaning. As you can see, look, 2 by 3. Why? Because now we're inverting the operations. And in this case, instead of summarizing, we will make just like a subtraction. I mean, 6 by 4. No, will not be. Instead of doing so, we're gonna take 3 by 4, and sorry, 6 by 4, and we're gonna use the 6. We will cancel the operation of the multiplication here, and we're gonna make uh, a multiplication by the numbers that we multiplied before. So we made a multiplication here completely as we did here before. The difference is just that we started from this side instead of the upper side. So now, to prove the last number is the most easy. I mean, it's just 1 by 3 by 1 is 3. And those are the two determinants. Now, if you want to see the whole result of this, is even more cool than what I can explain. The determinant of A is equal to 3 by 24. So I can take from my phone, for example, and I can say, "Hey Google, 3 by 24." 3 3 by 24. No. Hey Google. No, I didn't say that. 3 by 24. Yes, it's the math calculation is 72. I can see it because it shows me it shows me a prompt result. So 72, we want to say 72, but we have to say, hey Google, for example. I can use the calculator as well, but I am using hey Google because it's kind of cool, you know. Hey Google, hey Google, hey Google, 72 by 3. Thank you. 72 by 3. Yes. 72 by 3. Now, 72 multiplied by 3. 300, no. 72 multiplied by 3. Yes, thank you. It says that is 216. So we just have to make to put here 216. And actually, on my notebook, I mean, in my book, I have that result. We can go here. Sorry, we can place here our and why we're gonna make a rest here. The thing is that when we're gonna determine something, the determinations is to determine a limit. So it is not to determine to determine the range, nor the dominions, nor the latitude, nor the age. It is to determine the the limits. So that's why we make a subtraction because we're gonna take the limits and we're gonna subtract them to the numbers that are supposed to be like the measurements of something, measurement of something. So let's put now here, sorry, minor, and let's put the result of the other determinant that we got that was vice versa to the one. We can even put here, for example, for it to be clearer, like this. That was not taught. I mean, the teacher didn't taught me that to put it like this, like that. To be honest, in the school, when I was in school, I learned that, and I remember that I learned it to do it in that way. If I am not wrong, my teacher was too very good when I was in the school. But let's go now, okay? 6 by 18 by 3. No. 6 multiplied by 18 multiplied by 3. No. 6 multiplied by 3 multiplied by 18. No. We have to break it down. 6 multiplied by 18. 6 multiplied by 18. No, AT&T, no. 6 multiplied by 18. 6 multiplied by 18. No. 6 multiplicado por 18. Look at that. It says the same thing that I said. When it just says it's voids. better than mine. So it is 100, 108. Okay, let's put it on parentheses like this. Let's make it 108 multiplied by 3. The thing is that I don't use this very much. That's why it is giving me so many errors. Hey Google, hey Google, hey Google. 108 multiplied by 3. So we got 324 here, and that is the result. So, what I'm going to do now is simple. I'm going to take, and after rebuking Gideon in the name of Jesus Christ, which is Legion, the demon, we're gonna go here. 216 subtracted by 324. Minus 108. Did you hear it? It said it. It said it. So minus 108. I want to copy here, paste, and substitute this 108. And we can put here that A or minor A is equal to 108. Like that. And we got the results. That's it. I mean, that is how we make determinants in maths. And why is this useful too in software engineering? Well, when you understand the determinants in software engineering, you are able to see how the workflow of for example, a cycling works. But sometimes we don't see it as in a, as in a mathematical way because we don't have problems that require us to use those knowledge. But if we get to a job where we have to use this kind of knowledge, we will have to use programming knowledge together with math knowledge. That's why it's good to know these kind of things: determinants, limits, functions, algorithms, um, logarithms, algebra, all those things, are important for us to be very, very good developers. That's my opinion. That was what I tried to teach you. Now, sorry for the whole time that we took on this complete class, but I know that you have learned a lot together with me because this has been a very complete class. I mean. I consider myself a very good person when explanation comes, and trust me, I try to do my best. It is not to brag; it's just to you to take advantage of it. See you in the next video, and thank you for your time.